Good morning, everyone. In fact, good morning, good afternoon, good evening, from based on wherever you are. I'm Aishwarya, and I would like to welcome you all to the afternoon sessions of Oracle Groundbreaker Yatra 2020, our online webinar series. So this is the fourth session of the day. Just give me a second. Sorry for that. So here we go. OG Yatra. So this is 14 days, 125 plus hours of learning, 7 tracks, and you can see all this details over here on my screen. So this is one of the largest users group webinar series, and I hope to see more participation from all of you. You enjoy and learn more along with us. For today, we've already had a few sessions. This is the fourth session of the day. We've got Oren with us, and we've got a few more coming up soon, through the day. About AIOG. So AIOG, so as you're probably aware, AIOG is All India Oracle Users Group. We've got chapters all over the country. Sangam is our annual conference that is held in Hyderabad and Bangalore every year. So since it's held in a couple of cities, it made us wonder, what about other cities? And so we started bringing OG Yatra. We started with the thought of bringing speakers to all the cities across India. With this aim, last year we visited 10 cities, but unfortunately this year we couldn't. So we thought we take it we take it online. But this gave us a unique opportunity. This gave us a chance to bring even more speakers from across the globe to you. So we've got around, as I mentioned, we've got around 100 sessions in the OG Yatra series alone. Other than that, we also conduct weekly webinar series. That's every Wednesday. So we encourage you to join these sessions, spread the word to your colleagues, and the more people there are, the bigger the network we build. So here's another thing. If you've not already taken this snippet, if you could take a snippet of this and post it on social media sites, that would be a great way to thank Oren for his time and help us spread the word in the community. So coming to our speaker, today we are really glad to have Oren with us. He's an Oracle-based director with 27 years of extensive and continuous experience on Oracle systems. He's worked as a developer, a DBA, a manager, and an instructor. That's a great portfolio of things. So with that, I think we'd love to hear from Oren and on his topic today. So I'd hand over to Oren. Oren? I'll stop my screen sharing. Yes.
Thanks, Aishwarya. Thanks, everyone. Hi, everyone. And I'll start my video. Hi.
Hello.
Thanks for having me. And I wish I could meet all of you face to face. But I'm trying to focus on the good things. So I've just realized that I can keep my reading glasses on for the whole session, because on stage I take them off and put them on all the time. Let me share my screen with you. Yeah, this is another thing. I like to show lots of code during the presentation. So I start every presentation with this slide, but today we don't really need it, right? I guess you are sitting close enough. So I have a table T with 10 million rows, and I want to add 2 new columns. B and C, numbers with check constraints. Same data type, same check constraint. So let's add the first one. I hope you see my screen. I hope so. Oh, great. I got a feedback. I need feedbacks. So let's alter table T, add B number with a constraint that B is positive. Let's execute it, and it took a fraction of a second. Now I'll add C. Same data type, same check constraint, with one small difference, this comma. And both syntaxes are legit. Let's execute it. And now I think I have time to introduce myself properly. So my name is Oren Akdiman. I'm an ACE director from Israel. I am an Oracle developer for 27 years now, started with Oracle 6, so I'm pretty old. I work for Moveit, where I'm responsible for the database development and administration. I use the nickname DB-oriented for my activity in the Oracle users community. I tweet about Oracle stuff. You're very welcome to follow me. It's DB-oriented. And I write about Oracle stuff in my personal blog, dboriented.com. So you're welcome to visit, download presentations, including this one, and read about stuff that I find interesting, and I hope you will too. So yeah, it ended. It took 32 seconds. So now we have B and C, and practically they are the same. There is no difference between B and C, but it took us a fraction of a second to add B and 32 seconds to add C. So there are two different ways to achieve the same goal here. And in general, in Oracle, many times we have different ways to achieve the same goal. And if we know how things work, and we know that there are different ways, and we know the pros and cons for each way, then we can understand the potential compromises that we may take, and then we can choose the best option for us. And I really like to know how things work under the hood. And I think this knowledge gives me power to optimize, for example. So this session is completely about constraints, and surprisingly, there are lots of things to say about constraints. Actually, I don't have enough time to say everything that I want to say about constraints. And it is basically the result of lots of tests that I did, and found things that many of them are not documented, and they help me understand how things work, and I like sharing this knowledge. So we'll talk about many different aspects of constraints. And let's start with the basics to make sure we are all on the same page. Let's start with the syntax. There are two ways to create a constraint in Oracle: the inline syntax and the out-of-line syntax. Inline syntax is in the context of a specific column. Out-of-line is in the context of the whole table. This is why sometimes we call them column-level constraints and table-level constraints. And it is very important to note that once the constraint creation is over, there is no difference between the constraints. The way that we use to create either inline or out-of-line doesn't matter once the creation is over. So let's see some examples. Using the famous HR schema, these are inline constraints. You can see that we define the column, the data type, and the constraint with no delimiters between them. And these are out-of-line constraints. We define a constraint on job ID, and it is detached of the column definition. Every constraint must have a unique name in the schema. We can give it explicitly, either inline or out-of-line syntax. And if we don't give the constraint an explicit name, Oracle will give it an implicit name, something that looks like this. We can add multiple constraints in the inline syntax for the same column. Here, for example, we have email with 3 different constraints. We can use the inline syntax also to modify an existing column, not only to add a constraint with a new column. Here, for example, we took employee ID and made it the primary key. If the constraint is composed of several columns, by definition, we must use the out-of-line syntax. In an out-of-line syntax, we must specify the columns. With the inline syntax, we are not allowed to specify the column because we are already in the context of a specific column. With one exception, which is the check constraint, because in check constraint, we have any valid SQL expression, so we have to specify the column name. But if we try to refer to another column, not the one which is our context, then we'll get an exception. Okay. Next thing is the states of constraints. Each constraint has a state, which is composed of several attributes. I'll talk only about two of them, very significant ones. First of all, validation. Each constraint is either validated or not. If it is validated, it means that Oracle made sure that all the records in the table comply with the constraint. If it's not validated, it means that we may have records in the table that violate the constraint. It doesn't mean we necessarily have invalid records. It just means that Oracle didn't check and didn't make sure that all the records comply with the constraint. Another attribute is enabled or disabled. Each constraint must be enabled or disabled. Enabled means that any DML statement that we'll do on the table, Oracle will enforce the constraint for it, for all the records that are affected by this constraint. If the constraint is disabled, Oracle doesn't enforce the constraint for any DML. So if every constraint is either validated or not, and either enabled or disabled, it means we have four possible states. The first one, enabled and validated, is the best one probably, because we know that all the data is valid and will remain valid in future DMLs. I think this is the best state to be at. And after all, I believe that we use constraints to keep our data valid. Data integrity should be in place, and this is what constraints are for. On the other side, we have the disabled and not validated state, which practically means we have no real constraint there. The existing data and future data may violate the rules. I can think only on one legit case for this state, and it is with views. Oracle allows us to define constraints on views, but only in the state of disabled and not validated, which means it's not a real protector of data. It's just some declaration of intents. Enabled and not validated is an interesting state, and it means that new DMLs cannot violate the rules, but existing data may violate it. And we'll see that it is a useful state in some scenarios, usually as an intermittent state, not as just as a temporary state. And this is the most weird one, I think, disabled and validated, because it means that we know the data is valid, but Oracle will not enforce it for DMLs. So how will it remain valid? Because once a constraint is valid, it was validated, it will remain valid until we choose to change it. Oracle cannot change it from validated to not validated by itself. So this is an interesting state, and if we have time later, I'll get back to it. You can think about it in the meantime. Let's talk about the creation process of a constraint. When we add a constraint, then by default, it is created with the keywords enable and validate. And the creation process is composed of two steps, enable and validate. Enable means that Oracle adds the constraint to the data dictionary, and from this point on, every DML will be enforced. So if, for example, we add new records, we know that they will be valid because the constraint is enabled. And then it does the validate step, which means that Oracle goes over all the records in the table and validates that each and every one complies with the constraint. If it finds one record that violates the constraint, the whole statement will be rolled back. Okay, and the constraint will not be created actually. So think about the time it takes to do each of the steps. To enable the constraint, this is a very fast operation because Oracle only needs to mark it in the data dictionary. The validation depends on the size of the table because it has to go over all the records in the table and to check them. Okay, so keep this in mind. We'll get back to it later. So now let's get back to the example I started with. I added a column and a check constraint on that column. I did it twice. Now we can use the proper terminology. I added B using the inline syntax, and I added C using the out-of-line syntax, the one with the comma, right? So what we have here in both cases is a single DDL statement that has two tasks to do, adding a column and adding a check constraint on that column. This is one DDL statement. It is an atomic, isolated statement. So the first step is adding the column, and this is a fast operation. It is a metadata only operation. In this case, adding an optional column with no default, it is a metadata only since Oracle 6, I think. Today, even if we add it as mandatory or with or without default values, it is also metadata only since 12c for all cases. And now we need to add the check constraint. And the check constraint means that we want to make sure that for all the records, this new column is positive. Now, since in the same statement, isolated statement, we added the column, then is it really necessary to go over all the records and checks that B is positive? It's not. It's not necessary, and this is exactly what Oracle does if we use the inline syntax. Oracle skips the validation phase. It just marks the constraint as validated, but doesn't do the actual validation because it says all the records, in all the records B is null, so it's okay. They don't do this optimization in out-of-line syntax, and this explains why it took me a fraction of a second to add B and 30-something seconds to add C. So this is a big difference one comma can make, and it's good to know about it. And sometimes a nice optimization turns into a bug. I create a table, TBL, and I insert 5 records into it. So now we have the column X with some records, 1, 2, 3, 4, 5. And now I want to add a new column Y with a check constraint that says Y is not null. I'm using the out-of-line syntax. And what should happen now? This should fail, right? Because we already have records in the table. If we add now Y, it must be null for all the records, and the check constraint Y is not null will be violated. Let's try to do it using the inline syntax. And we succeed. So now let's take a look at user constraints. We have a constraint says Y is not null. It is enabled, it is validated, and it is null in all the records. Isn't that cool? I think it's cool. Why did it happen? Let's see how check constraints are evaluated. A check constraint has a check condition, a Boolean condition. In this example, Y greater than 0. And this condition is Boolean, and therefore it is evaluated to one of 2 values, either true or false, right? Actually wrong, because it is evaluated to one of 3 values, true, false, or null. And a record is considered valid if it is not false, if the expression is evaluated to either true or null. So if we take a look at this example, when Y is null, Y greater than 0 is null as well, which is a valid state for check constraint. Or Y in a list of values, same thing. Or Y equals trunc of Y, same thing. But if the expression is null aware, like Y is not null, then when Y is null, Y is not null is false. Or this example. This expression knows about the possibility that Y will be null and handles it. So while doing the optimization of the check constraint with the inline syntax, Oracle assumes that the check constraint will be evaluated, the check condition will be evaluated to null for a new null column. Most of the times it is true, but not always, as we've just seen. Now, in this case, we used the check constraint for enforcing Y is not null. We can use another type of constraint, which is the not null constraint. And we'll talk about the differences, but let's first talk about specifically about not null constraints. Oracle has a nice and dedicated optimization for adding a column with a not null constraint to a table. If we trace it, we can see that it does this query: select nothing, 1, from the table where row num equals 1. This should be a fast operation, right? Because we stop after 1 record, and it doesn't matter how big the table is. If we get no row selected, it means that the table is empty, and it is okay to add a new mandatory column to the table. If we get 1 row selected, which means the table is not empty, and we get this exception, table must be empty to add mandatory column, which makes perfect sense. If we want to add a mandatory column to a table that is already populated with records, we can still do it, but we have to use the default clause. We add y with default 42 and not null. Before Oracle 11, this could take a lot of time because Oracle had to go over all the records in the table and set y, add y, and set it to 42 in each and every record. Since 11G, this is a metadata only operation and an online operation, and it is very efficient. So back to the question, is this check constraint, y is not null, and this not null constraint are the same? In principle, they are the same because they should achieve the same goal, right? But I find, I think, 7 differences between these two constraints. Let's go over them quickly. I'm creating a table T3, and I have the column NN with a not null constraint, and the column call CHK with a check constraint that says call CHK is not null. In principle, they are the same. They serve the same goal. The first difference is just semantic. We can add the not null constraint only using the inline syntax, while the check constraint can be added using the inline syntax or the out of line syntax. Not a big deal, I know. The second difference, if we look at user constraints, we can see that for both of them, we have a C constraint that says column is not null. Call CHK is not null is the one that we explicitly added. Call NN is not null is a check constraint that Oracle implicitly added. And I think this is the main reason why people many times think that these are exactly the same things, but they are not. The main difference that affects all the rest of the differences, I think, is that in user tab columns, in the data dictionary, there is a nullable column. And for a not null constraint, it is, it is N, no. And for call CHK, it is Y. It is yes. So the next difference, when we describe the table, we can see that call N is specifically not null, but call CHK is not. And this difference comes from the previous one, the nullable column in the data dictionary. If we try to violate the constraint, so for the check constraint, we get the rather generic exception, check constraint violated. For the not null constraint, we get a more explicit exception, cannot insert null into the specific column. The optimizer, what it has to say about the constraints. Let's look at this statement. Select star from T3 where call NN is null. Since we know that the column is defined as not null, this should not return anything. And the optimizer knows it. So it adds the filter step here in the execution plan and says null is not null, which is a different way to say never. And the cost is 0 because it will never access actually the table. The same query for call CHK, the optimizer ignores this or is not aware of it, and it scans the table and visit every record and checks that call CHK whether it is null or not. Another example regarding the optimizer, let's create an index, a B-tree index on each of the columns. On call NN, we created a B3 index. And if we select :n from T3, we know that each and every record will be in the index because we don't have nulls there. And the optimizer knows that it can simply scan the index and get :n from the index for all the records. If we do the same with call_chk, the optimizer goes to the table itself and does the more expensive operation. Now, the big question that I have is whether the optimizer really can't or just won't. Because the optimizer is very, very smart. And it's not that it ignores check constraints at all. If, for example, we add a constraint that says call_chk, a check constraint that says call_chk is less than 1000, and then we try to select from the table where call_chk equals 2000, the optimizer knows that no rows will respect this condition, and it gives us a very good execution plan that costs 0. So I don't know why the optimizer ignores specifically this check constraint of something is not null. The last difference, I create a view on top of the table, v3 as select from T3, and I create a procedure that references the columns in the view. Okay, so we have P3, it does nothing. It just references the columns in the view that in turn references the columns in the table. At this point, the three objects, the procedure, the table, and the view are valid. If I drop the not null constraint, it causes invalidation of the view that in turn causes an invalidation of the procedure. Okay, and I personally don't like invalidations. Let's recompile so everything is valid again. And now if we drop the check constraint, everything remains valid. So this is, from my perspective, a big pro to the check constraint over the not null constraint. So we talked about check constraints and not null constraints. What about foreign key constraints? I have a table T1, and I want to add a new column to T1, category ID, with a foreign key to the categories table. Let's first do it in two different steps. First, I'll add to T1. T1 has 1 million records. First, I'm creating the categories table, and then I add the new column, cat ID, to the table T1. This is a very fast operation, metadata only, as I've already said. Now, adding the constraint as a separate operation takes time. It takes here 3 seconds, during which Oracle had to validate that all the records in the table comply with the new constraint. It is okay, it is legit because we did it in 2 different statements. Now, if we trace this validation phase, we can see exactly what Oracle does. It looks for records in T1 where cat ID is not null, and then it does an outer join with categories and looks for records in A that do not point to records in B. Now, but my main point here is this condition, cat ID is not null. Foreign keys, by definition, are enforced only for non-null keys. This is why Oracle looks only for records in A with cat ID is not null. Now, if we add the column with the foreign key constraint in a single DDL, once again, we have here two tasks, adding the column and adding the foreign key on that column in one atomic isolated operation. So we know for sure that after adding the column, it is null for all the records, and therefore, for sure, it does not violate the constraint that we've just adding. So let's see if Oracle knows it too. And the answer is yes. We added the cat ID2 column and the foreign key in a single DDL, and it took us a fraction of a second because Oracle utilizes this optimization, marking the constraint is validated without actually doing the validation. This is really good thing, and this optimization applies both in the inline syntax and the out-of-line syntax. So what's the catch? We've seen that adding a column and a constraint in a single DDL is a fast operation, while doing it in two different steps. The first one, adding a column, is fast, but adding the constraint is slow for big tables. And the bigger the table is, the slower it will be. There is another benefit for doing it in one statement. It is an atomic operation. If we do it in two statements, then after adding the column and before adding the constraint, someone may insert records into the table that violate the constraint that we were just about to add. So what's the catch? The catch is that a single statement is an offline operation, while two different statements can be online. But what is exactly the difference between offline DDL operations and online DDL operations? So in short, I would say that offline DDL operations are rude, disrespectful bullies, while online DDL operations are polite, well-behaved gentlemen. What do I mean? The offline DDL operation acquires highly restrictive table locks, share or exclusive lock, while the online DDL operation acquires the modest types of locks, like row exclusive or row share, very much like DML operations. Now, if the offline DDL doesn't get the lock that it wants, it will immediately throw ORA 54, which says resource is busy. The online DDL will wait idle for active transactions to end, and only then will be applied. And once it gets the lock, the offline operation will block any new DML statement, while the online operation does not block DML statements, new DML statements. Let's see it in action. So first of all, let me see if this will work. Yeah, I hope you see 4 screens now for Windows. I will use the blue one for monitoring the locks, the white window for DDL statements, and the black sessions for DML operations. And first of all, I want to show that adding a column and a constraint in one DDL is an offline operation. By the way, the SQL prompt here is the SID 245360. It will help us see the locking. Right now, nothing is locked. So I'm creating a table T2, and I insert a record into T2, and I don't commit. So now I have an open transaction. Okay, so we can see that session 245 has a lock, row exclusive lock on the table. And now I try to add a column and the check constraint in the same DDL, and I immediately get OR54 because it is an offline operation. It wanted to get an exclusive lock on the table. Let's try to change DDL lock timeout to 20. This is a configuration added in 11G. It means that in this session, DDLs will wait up to 20 seconds while trying to get a lock. This is a dangerous configuration, and I'll show you why. So I'm trying to add the column with the check constraint, and then I try to insert a record into the table, and I'm blocked. And let's take a look what happens here. 245, this one, has a row exclusive lock on the table. 302, the DDL, wants to get an exclusive lock on the table, but it is blocked by 245. And then a new DML, an innocent one, wants to insert a record to T2. So it only needs a row exclusive lock, but this one, the white one, 302, is standing in line in front of it, and it blocks every other DDL. So although 302 did not get the lock that it wanted, while waiting in line, it blocked new DML statements. So using DDL lock timeout may be dangerous. Remember this. And as I told you, it is a bully disrespectful guy. Let's roll back. And let's set DDL lock timeout back to 0. And nothing is locked anymore. So we've seen that this is an offline operation. Now, if we do it in 2 statements, so adding a column is an online operation. Let's see it very quickly. I insert a record into T2 and I don't commit. And then while trying to adding a column, I'm trying to add the new column, just the column. And this is an online operation. It sits idle and waits. And while it waits, while it is waiting, a new DML can insert record into the table with no problem. Okay, we can see here that 302 is blocked by 245, but it doesn't request anything. It just has row exclusive and it waits to 245 to commit. Let's commit and table altered. And now note that the table altered, although we have another session that is still not committed. Okay, it's okay. This is an online operation. It is a real gentleman. And we can see already the new column B, even from this session. Okay, so we added the new column and it is an online operation. What next? Now we want to add the constraint. Now, by default, adding a constraint with enable validate, which is the default, is an offline operation. But remember this slide, we know that adding a constraint by default is a 2-step operation, enable and validate. And we can split it into 2 operations. We can first add the constraint without validation, and this is an online operation. And then we can do the validation step, which is also an online operation. Obviously, this is not atomic anymore, but usually, for me at least, it's okay. Let's see it. I'm updating the record that we have in the table. set b to -1, and then trying to add the constraint. By default, it is an offline operation. I get OR 54 because I cannot get a lock, a restrictive lock on the table. But if I try to edit the constraint using enable no validate, which means do just the tiny step of enabling the constraint, I'm waiting here. It is an online operation. And actually, I said that online operations are polite. This one is too polite because it has no reason to wait for the 245 session to end. Let's see it from another session. We select from user constraints and it is already there. It cannot roll back now. The constraint is there with the condition, it is enabled and it is not validated. And because it is enabled, we cannot insert a new record with -2. The check constraint is there. It does its job. Actually, even if I kill this session now, everything is okay. It is already there. Too polite. Let's commit, table altered. And now for the validation phase, first of all, I cannot validate. Why I cannot validate? Because I updated the record here to -1. And I did it before adding the constraint. So now if I try to validate, and this is how I do it, alter table, enable validate constraint. Check constraint violated. Okay, let's fix this. Let's set it to a positive value and commit. And let's open a new transaction, updating the record to something without committing. And let's even have another transaction, insert into the table a new record. So we have now 2 open transactions with row exclusive locks on the table. But this operation of validating, only validating the constraint, is not just online, it's very online operation because it succeeds with no problem, even though we have open transactions. And the idea here, and I think it's a genius idea, that first Oracle enables the constraint. So it puts a guard in front of the table. And then it only needs to validate what was already existing in the table before that. This is why it doesn't need any lock now. Okay, let's continue. What about unique constraints? I want to add a new column Z with a unique constraint on it. So it makes sense to do it in a single statement, right? Let's do it. And it takes time. Let's see why it takes time. When I do it in a single DDL, like before, it is a statement that's composed of several steps, adding the column, adding the unique constraint on that column. And here we have another step. In order to enforce the unique constraint, Oracle creates a unique index on the column. Now we are adding a new column, which is null in all the records. And we create a B tree on this column, which is null. And the B tree does not contain entries for entirely null keys, right? So by definition, the index that is created here must be empty. Now it took us 34 seconds to create an empty index, an index that we knew from the beginning it would be empty. And just to prove it, let's select from user indexes. It has 0 blocks and an empty segment. So I think that it's a real waste of time. And moreover, during this time, of creating the index, the table is locked in a restrictive mode. This is from the trace. We really created a unique index by a full table scan. And I have an idea for Oracle, and if you agree with me, so you are welcome to upvote in this link. You can scan the QR. I think it will be wonderful to create an empty index in this case. It will save time and it will improve availability. Okay, so it doesn't give us any benefit to add the constraint, the column with the constraint itself. I see that my times is almost up, and I want to let you ask questions. So I'll skip this part. You have it in the presentation, and you can read. I wrote a series of posts in my blog about constraint optimization. So if you are interested, come and visit the blog. Just one last thing about foreign keys and constraints. This is another cool thing. I have a parents table and a children table with a foreign key between them, and I want to drop the children table. So for that, Oracle will acquire an exclusive lock on the children table. It makes sense, it's okay, it's wonderful. But for some weird reason, Oracle also tries to get a shell lock, a restrictive lock, on the parents table. Now, I can't think of a good reason for that, but I do have two workarounds to do it. So I'll just show you. I'm creating the parents table, and I'm creating the children table with a foreign key to the parents table. Let's insert one record into parents and commit. And now let's get a lock, a simple lock on the record in the parents table. And now I want to drop the children table. If I try to drop table children purge, I cannot, okay? Because it tries to get a share lock on the parents table. Let's try to disable the constraint. And surprisingly, I can disable the constraint, although the parents table is locked. But it doesn't help me because I still cannot drop the children table. Okay, what about dropping the constraint? I can drop the constraint with no problem. And now there is really no reason for Oracle to stop me from dropping the children table, of course. So this is one workaround. Let's quickly do the second one. I recreate the children table with a foreign key to parents. I lock the record in the parent table. I'm trying to drop the table, the children table, and I don't succeed with the purge option. But if I try to drop the table without purge, which means that the table is still there, but in the recycle bin, right? I'm selecting from user recycle bin, and I see the table there. And now I can purge the recycle bin, and the table is gone, and the recycle bin is empty. Okay, so thank you. And now let's see if we have some questions. Yeah, I see one question. What is the significance of state during data pump? I'm not sure. Well, obviously, once the data pump is over, the state should be the same as it was before when we took the export. When will we find the document? So first of all, in my blog, there is the PDF of this presentation, and I will upload it right after in a few minutes to the AIOUG site. Any more questions? Oh, I see in the chat we have some questions. Let's go there. Okay. I have some comments here that are not questions. Okay.
There is one more question, Oren, in the Q&A panel.
Yeah, what is TS contention and row lock difference? I'm not sure what TS, I don't think I showed TS. Can Suvankar, can you please elaborate? Or just send me an email or tweet. What's the best place to find in-depth understanding of how Oracle works internally? Well, some of the stuff is documented in the, I would start with the concepts guide, but many things are not documented, and I get it, because Oracle, if they document how something is working under the hood, they have to maintain it, and if not, they can change it and improve it over time. So I like to test things, and this session and the series of posts I wrote is about, it came from testing lots and lots of scenarios and trying to understand how things work. And this is what I tried to share with you, I hope, that successfully. Any more questions? TX contention lock. Oh, okay. Back to the previous question about row lock difference and TX contention. Well, I don't think I have enough time to dive into the locking mechanism of Oracle, which is magnificent. So either send me an email or tweet, and I can refer you to good content, or just Google it. Judith, have you tried using disable table lock as a workaround for dropping the child table? No, I did not try to disable table lock, but I do have 2 workarounds that work. Okay, any more questions?
No, I think, Oren, I think we've got, we're running out of time as well now.
Okay.
Okay.
Great. So, as I said, if you want to ask me more questions, you know how to contact me.
Yes, thank you. I will just start sharing my screen. So a reminder to everyone, in order to to thank Oren for his time, could you just use his Twitter handle and connect with him over Twitter? You can ask him your questions over there. moving on. This is just a reminder about the Learn and Win series that we have. This is a great chance for everyone to win. This is a great chance for everyone to get or earn our
Actually,
membership.
sorry to interrupt you. I think the slides are not moving.
Slides are not moving.
Right, the presentation is going in another screen, maybe.
No.
Vinay, can you confirm?
Yeah, presentation is not visible. Can you click on the present in the screen side, Ashwin?
Let me just do that again. Just 1 second. Can you see this now?
Yeah, it's go ahead with the small presentation only. Yeah, we can see.
It's fine. We can do it.
Okay, sorry for that. So this is about the points that we were mentioning. We've got this point system where you can, that is based on the sessions that you've already attended and you are attending. So 1 minute is valued at 1 point. So for example, that you've attended this session, you've already earned 60 points. So the more sessions you attend, the more chances you have to win get a chance to win up membership. We also have bonus membership, bonus points, which you can, based on your social media activities, which we have already detailed in the delegate letter, where you need to just take a snippet and of our OG Yatra badge and your photograph with the badge and share it on the social media platforms. You can visit the delegate newsletter for more details. So as you can see, we have 4 types of recognitions based on the points, where 1,000 to 3,000 points will give you bronze membership, 3,000 to 5,000 would be a silver, and so on. You get 5,000 and above, 5,000 to 6,000 gold, and 6,000 above would give you a chance to win the platinum membership. And along with that, there are also certification badges and participation certificate and badges that you can use in LinkedIn as well as Twitter. So let me see if we go to the next slide correctly. This is about the kids track that we've just announced earlier today. So the registrations are now enabled. You can register. This is a robotics track where for your kids this is on Sunday, based on certain age groups like 8 to 10, 11 to 13, 14 years on. So you can register and participate accordingly. And the last thing before we leave, I'd like to say that I've already covered, please continue the conversations using the tags. Regarding the presentation material, it will be accessible through the AIOG portal after Yatra completes. On 4th of July, we've got some really special keynotes, fireside chat, which unfortunately, it's not a live fireside chat like we used to have during our on-premises or in-person events, but we are trying to do the best we can so that you get an opportunity to interact with as many people as you can and discuss your questions and network. Along with that, we also have a session by ACES and Java champion community of India, where they would be, sharing their experiences, their journey about their experiences and the journey. Again, this is the 12th July Kids Track that I just mentioned about, and the most important thing is the speaker feedback. If you could just scan this QR code, you would be taken to a survey link where we would really appreciate if you could provide us the feedback, or if you have anything more that you would like on, about this session, anything. So it's a short survey. We would really appreciate your feedback. Next up, we've got on the next session that's coming up shortly. That's in half an hour. That's Sahid's session. So we hope to we're hoping to see you again in that session. And Orun, thank you again for your time.
Thank you.
We really appreciate it. Thank you.